Question 8.1. One of the programs used by FairlyFit is used to store and work with details of various food items which are sold in the cafe. The program makes use of objects to hold relevant information and is made up of many different classes. The stock class. This class will be used to instantiate stock objects. One object for each stock item bought for sale in the cafe. Each stock object will have the following fields: description, which holds string values; stock quantity, which holds integer values; cost price, which holds real values. Real can be thought of in this case as numbers which can also hold numbers with decimal in it. Now, because this is a price, using real as the data field makes sense because prices have decimal numbers within. Now, selling price, which takes real. And finally, healthy food, which is a boolean. Boolean can hold two values, either true or false, yes or no. These fields should only be accessible from the stock class. Additionally, the class will need to have the following class fields: markup, which takes integer values. This value is fixed at 60. Total stock, which takes integer values. This represents the total number of all food items in stock. Total cost, which takes real values. This represents the total price of all the food items in stock. Total sales, which takes real values. This represents the total value of all food items sold. Except for the markup field, these fields should only be accessible from the stock class. Now then, before we move on, check the video description, and in it you will find links to videos that explains every single thing that a total beginner needs to know about UML, or those who aren't technically beginners and still need to revise. I cannot emphasize it enough. Okay, now let us move on. Complete the following class diagram for the stock class. Show the declaration of additional fields as well as the following methods. Before we move on, let us discuss what we're looking at. This is called a UML, defined as Unified Modeling Language. Now, this unified modeling language is how programmers can create real-life programs based on this simplistic depiction of what the program should have. Stock class. Parameterized constructor method accepting the following parameters: D, which takes in string; SQ, which takes in integer; CP, which takes in real; SP, which takes in real; and HF, which takes in a boolean. Accessor methods for the healthy food and stock quantity fields. Mutator method for the description field, which will accept a string parameter, which is called DIN. Accessor method for the total stock field. And finally, a toString method to combine the various field of a stock object into a single string. Now, we shall discuss for a moment and try to remember what the video link described for us about these terms. The first thing that we'll look at is the incomplete diagram. We see that in the field section, there is a minus sign. According to the knowledge that we now have, we will recognize that the minus sign represents private. Minus means private. So here we see that the description field has a private visibility modifier. It accepts a string. The stock quantity is also private, which accepts integer. The cost price is also private, the selling price private, the healthy food private, which accepts real, and boolean in that order. We are told that except for the markup field, the rest of the fields should only be accessible from the stock class. We have to understand what a markup is for us to answer this particular part of the question. So according to the dictionary, a markup is the percentage or amount by which a seller hikes up his buy-in price when determining his selling price. So it is represented as a percentage. So we know that every single object that is going to be sold will have a 60% increase in price, which acts as the seller's profit. Because of this, we now understand that every single object will share this 60%. Because of that, the markup field will be static. Static variables are always represented as underlined. Except for the markup field, these fields should only be accessible from the stock class. This information tells us that the markup field is public. So now that we've written that, the price of each of variables like veggie burger, fish sticks, salad, smoothies, or protein shakes will have a 60% profit that will go into the business. So that becomes the static object. We underlined it and it indicates static. Take a look at the keyword fixed. That will be the only explicit information that will tell you that the variable is a final, meaning that it is constant. Therefore, the markup should be written in all caps. So the rest are going to be private because, as stated, only the markup field should be accessible outside of the stock class. So we put a minus sign. We see that the total stock is a representation of every single object, which is veggie burger, fish sticks, salads, blah blah, and every other thing that Fairly Fit will sell. So now total stock would represent the total number of all the food items in stock, meaning that it is a shared number. Therefore, we make this static, and it accepts an integer value. Next is total stock. So long as you see all food items, just know that it's going to be static. So we go to total cost, which takes in real values, and finally total sales, which takes real values. Next, the methods. We're asked to create a parameterized constructor method accepting the following parameters: the letter D, which takes in a string, the letters SQ, which takes in an integer, CP, which takes in real, SP, which takes in real, and finally HF, which takes in a Boolean value. Constructor methods are always public, therefore we represent this using the plus sign. Minus sign represents private, plus sign represents public. Now, we start by writing constructor. We are told that the letter D, which represents description, takes in a string value. Therefore, we type D, then colon, then string. Next is SQ, which takes in an integer value. Next is CP, which takes in a real value. Next is SP, which takes in a real value. And finally is HF, which takes in a Boolean data type. Next point, we're asked to create accessor methods for the healthy food and stock quantity fields. Accessor methods are also always public. Therefore, we start by writing plus. Afterwards, we must understand that accessor methods are getters. They get, therefore, we start by writing get before the method name. So we type get healthy food. Getters always take in no parameters and they return the data type which was stated in the field section. As we can see here, healthy food takes in a Boolean, therefore the method to get healthy food must return a Boolean value as well. We're asked to create another getter called stock quantity. So we start with get stock quantity. It takes in no parameter and returns exactly what it took in the field section. Stock quantity in the field section took in an integer, therefore it returns an integer value. Next point, we're asked to create a mutator method for the description field, which will accept a parameter din and takes in a string value. Mutator methods always start with the keyword set, and mutator methods are also always public. Therefore, we write plus, then we type set, and then the mutator name, which is description. Then we are told that we are to call it din, and that this takes in the data type string. Mutator methods always return nothing. We represent nothing by typing the word void. The direct definition of void is containing nothing, empty, not occupied, or filled. In other words, they return nothing in the language of coding. Whatever comes after a method that isn't the constructor is what it returns. In the first case of healthy food, it returns a boolean that is after the colon. The second case, in stock quantity, it returns an integer. And the last case, which we are in right now, in description, is that it returns nothing, which is represented by void. Next point, we're asked to create an accessor method for the total stock field. Accessor methods are always public, and we start with get. Now this total stock must also return an integer as stated in the field value, as you can see here, integer. Therefore, because it takes in an integer there, it must return an integer in the method. But we're not done. We see that it is static when we initialized it in the field section. In order for it to be compatible and in order for it to work in the actual codes, this method must also be static. Therefore, we underline it. Now it is correct. We move on. Finally, we're asked to create a toString method to combine the various fields of a stock object into a single string. We type toString, then we set it to return a string. And there we have it. We're done. In order for you to have been able to answer this particular part of the question, you need to have been familiar with these concepts. Some of you may be curious about how this UML diagram might be able to help a programmer create an actual program based on this representation. So for those of you who are curious, this is how it would look like. As you can see, the first thing is what were provided before we started answering the question. A private string method which is called description, a private integer method which is called stock quantity, and so on. Next are the static methods which are shared by every single object that we create. The lentil salad, the power oats, the protein wrap, and the prego snack will all share these variables. Therefore, we made it static by underlining it, and you can see here that the programmer understood that it was static because it was underlined and named it static as so. The next thing was the constructor method. As we can see here, the constructor isn't technically named constructor, but it is given the exact name as the name of the class. When typing out the program in real life, the constructor method would always be the same name as the class. Therefore, the constructor in this case is called stock. Inside the parameter of the constructor, these brackets, we see that the data type comes first before the name of the data type, which is description, which we were given to write as D. Next is the data type for the stock quantity, which we are given as integer. Next is double for cost price, double for selling price, and finally the Boolean data type, which was named healthy food. Next, we set the fields equal to what was inserted inside the constructor. So as you can see here, the description, which was made private here, was set equal to what was put into the constructor, which is D. So the description is equal to D, the stock quantity is equal to SQ, the cost price CP, selling price SP, and finally healthy food HP. Now some of you may have been curious about how the total stock and the total cost would have been calculated after each object was made. This is how. Whenever each object is made, whatever value was inside the total stock would add to the stock quantity of the object that was newly created. In the same way, the total cost would add to the cost price multiplied by the stock quantity of the newly created object. That way, the total cost and the stock quantity would always be updated whenever a new stock was created. Next are the getters and the setters. As we can see here, the plus sign was put as public when was coded. Its return type was Boolean and it took no parameters. As we can see here, it returns the healthy food status of the object. The next one was the public. The next one was the stock quantity, which was set as public, and it returned an integer value. The next one was the mutator method for the description. As we can see, it is called set description. It is set as a public visibility and it returns nothing. What it does is that it updates this description into what was put into the parameter here in DIN. Finally, it is the accessor method for the getTotalStock. Because the field value was set to a static, the public method must also be static. Therefore, as you can see, it has a public visibility, it is static, its return type is an integer as stated by the field value, and it returns a total stock, which was an integer value as well. This means that whenever we run this program and we call on this method, we won't get an error message because both the field and the method was set to static. The last one was the toString method. Whenever we call in the toString method, the first thing is that we override it and then we create the toString method. As was stated, we're supposed to create a toString method to combine the various fields of a stock object into a single string. So whenever this toString method is called, it will return the description, the stock quantity, the cost price, the selling price, and the healthy food of that particular object. So this is how the executable program would look like. As you can see, Fairly Fit's healthy food store is called Freshly Fixed. The first product or object that we're going to put into the program is lentil salad. The stock quantity has been set to 8. The cost price has been set to 5 Rand 50 cents. The selling price has been set to 8 Rand 80 cents. And finally, the healthy food status is yes. Once we click add stock, we'll get an error. From this, we see that the validation rule works. It says invalid input. Please enter valid numbers. Okay. The problem here was that we put a comma instead of a period sign. So let us change it to a period sign. Then once we add stock, take a look at the records section. Now let us discuss what this button does. As you can see, this button calls on the toString method. And we remember from the instructions that the toString method was supposed to combine the various fields of a stock object into a single string. And that's exactly what it did here. Next, let us add another product whose healthy food status is no. We will choose Prego steak. The stock quantity has been set to 15. The cost price has been set to 12 Rand 80 cents. The selling price has been set to 20 Rand 48 cents. And we will not tick this checkbox. Let us add stock. As you can see, it is working perfectly. Now, the question lies, what does the View Total Stock button do? Let us click it and find out. From here, we see that the View Total Stock calls on the getTotalStock method. It adds the total stock of all of the products in the program to give us the total stock that is currently available in the store. Let us try this again. Let's see if it will still work. Let us add the product Power Oats. The stock quantity has been set to 15. The cost price has been set to 4. The selling price has been set to 6 Rand 40 cents. And the healthy food status has been set to yes. Let us click add stock. We click it, and as we can see, until we click the View Total Stock button, this number will not change. Now let us click it. As you can see, the number correctly added, 15 plus 15 plus 8 gives us 38, which is true. Now, let us look at the code behind the buttons. We can see that the code behind the add button is wrapped around a try and a catch statement. This is for validation. Now let us take a look at the code inside the try statement. As we can see, the first thing that we did was created variables to collect the data which was in each specific text field. From here, we can see that the variable for description has been set to a string data type, and it collects data directly from the description text field. The next one is quantity, which collects the data as an integer data type. The one after that is cost price and selling price, which both collect it as a double data type. The last and final one is healthy food, which collects it as a Boolean data type. As we can see from the integer, double, and double data type, there is a conversion. The conversion is because every text field stores data as a string data type. Therefore, we have to convert it from a string data type to its respective data type, which in the case of quantity was integer. Therefore, we use integer.parseInt. And for the cost price and the selling price were double. Therefore, we use double.parseDouble. The healthy food, on the other hand, was just a checkbox. Therefore, we did not need to convert anything. From there, we see the practical usage of the stock class. We see that we did not create a new code altogether, but instead we utilized the stock class from what we had created. We called the stock object stock item, and we immediately called the constructor. After calling the constructor, we inserted the variables which we created, respectively description, quantity, cost price, selling price, and finally healthy food. As we can see from this line of code, the text area which we previously saw called the toString method, then added an empty line to separate each object. Afterwards, it cleared the fields in the text fields. That is the code behind the add button. Now, let us take a look at the code behind the view button. The view total stock button only has a single line of code in it. As we can see, what this does is that it directly accesses the getTotalStock method. Then afterward, it converts it into an integer and sets it to the label which we saw in orange. Before we move on, it is important that we take a quick look at the coded example of the private keyword. This will help us understand the importance and reason why we make things private in codes. I've created an empty folder and named it private example. Here we're going to create a new class and we'll call it bank account. The first thing that we're going to do is to create an instance variable called balance. We will make this a private data type which holds real numbers. We're going to type private double and then we name it balance. Double is the coded property of real numbers in Java. Next, we're going to create a constructor. Constructors, as we said, are always public. So we're going to name this constructor the same name as the class, as was stated. Every constructor must have the same name as the class. Therefore, we type public bank account. Now this constructor must accept a double data type. And we're going to call what it accepts initial balance. Here, we're going to set the instance variable equal to the value of the constructor. So we're going to type balance equal to initial balance. Close curly braces. Next, we create a getter for the instance variable. We type public double and then we name it getBalance. It takes no parameters and it returns balance. Next, we create another method called deposit. This method is similar to the mutator method. It does not return anything. Therefore, we type public void to indicate what it returns, which in this case will be nothing. Then we type the name, which we call deposit. This method must accept real numbers. We use the double data type. Then we call it amount. The first thing that it must do is check if the amount is greater than 0. Because you cannot deposit a negative amount, so we use an if statement. If amount is greater than 0, then it must run this code. Balance is plus equal to amount. This is a short form of writing balance is equal to balance plus amount. All you have to do is write balance is plus equal to the amount. This works the same way. What we're trying to do here is set whatever value was inside balance and add it to the amount which was put in this method. If the if statement is false, nothing will happen, so we can just leave it as is. The next thing we're going to create is a method called withdraw. We'll make this a public method and it returns nothing, therefore we use the keyword void. We name it withdraw. This method will accept a real number, therefore we use the double data type, and we call it amount as well. The first thing that this method will do is that it will check whether the amount you're trying to withdraw is greater than 0. If it is greater than 0, then it will check whether the amount that you're trying to withdraw is greater than what you have in your bank account, because you cannot withdraw more than what you have. So we use the if statement. If amount is greater than 0 and the amount is smaller or equal to your balance, then it will run the code. It will withdraw the amount that you put in the method from the balance that you have in your bank account. So balance minus equal to amount. And there we have it. A short and simple code. Now then, let us use this to discuss the essence of why we make things private. The first reason is data integrity and control. First point. Variables are kept or made private because it helps to prevent unintended changes. By keeping variables private, you prevent other parts of the program from directly modifying them. This ensures that the object state cannot be changed in unexpected or inappropriate ways. The second point, controlled access. Private variables can only be accessed or modified through methods like getters and setters. These methods can include checks and validation to ensure that any changes to the variable are valid and maintain the integrity of the object. The second reason is abstractation. Hiding implementation details. Keeping variables private hides the internal workings of a class from the outside world. This is part of the abstractation principle, where you expose only what is necessary and hide the complexity. The second point, simplified interface. By using public methods to interact with the object, you provide a simpler and more intuitive interface. The users of the class don't need to know how the data is stored or managed. They just need to know how to interact with it. For example, we as grade 12 learners don't necessarily need to see the internal workings of the codes double, boolean, integer, string, and so on. It will be overwhelming, unnecessary, and simply preposterous. How on earth do you expect us as grade 12 learners to know all of this? One might ask. But for those of you who truly are interested, you can hold Control button and click on the data type once you've typed it, and you'll see the intricate details that makes up that particular data type. However, it is simply unnecessary to learn those things as of yet, unless you want to. It's completely your choice. But to those of us who are completely focused on passing our exams and keeping our eyes focused on the problems that has been set before us, knowing the intricate details of these data types is simply unnecessary. And now we can appreciate this second point, simplified interface. We simply do not need to know the complexities as of yet. The third reason, flexibility for future changes. First point, easier maintenance. If variables are private, you can change the internal implementation without affecting other parts of the program. For example, you might decide to change how a variable is calculated or stored, and as long as the public methods remain the same, the rest of the code won't need to be changed. This part is very much useful for those of you who are doing pets. Believe me. Okay, the next point, encapsulation of business logic. You can include business logic within the class methods to enforce rules or constraints. For example, if you have a set price method, you can ensure that the price is never set to a negative value. The next reason is security. First point, protect sensitive data. If an object holds sensitive data like passwords, user data, etc., keeping the data private ensures that it isn't accidentally exposed or altered by unauthorized parts of the program. The next reason is encapsulation. Encapsulated object state. Encapsulation is the practice of bundling the data, aka variables, and methods that operate on the data into a single unit or class. By keeping variables private, you ensure that the only way to interact with the data is through the methods you define, which helps maintain the integrity of the object. Take a look at this. In our coded example, we made balance private. By keeping balance private, you prevent it from being directly modified by outside code. For example, setting it to an invalid value like balance is equal to -1,000. The if statements that we put within the mutator methods helped us with this. The second point, controlled access. Access to the balance is controlled through the get balance, deposit, and withdraw methods, which ensure that the account behaves correctly. For example, you can't withdraw more than the balance. In summary, keeping variables private is about protecting the internal state of an object, enforcing rules and constraints, and provide a clear and stable interface for interacting with the object. This leads to more reliable, maintainable, and secure code. This private example was made possible by ChatGPT. Next, we're going to discuss the final keyword. This is represented in all caps in the UML. In Java, the final keyword is to define constants and to ensure that a variable, method, or class cannot be modified after it has been assigned or declared. Final variables. The first point. Final variables are immutable values. When you declare a variable as final, it means that once it's initialized, it cannot be changed. This is often used for constraints. A ChatGPT example. We have our public class called employee. As we can see in the code, it has private, which is the visibility modifier, final, integer, and it is called employee ID. Then we have public, which is its visibility modifier, static, which indicates that it is a shared value, final, which indicates that it is immutable, and finally double, its data type. It has been named starting pay rate, which is equal to 15. In this example, first point, each employee object has a unique employee ID, which is assigned when the object is created and cannot be changed afterwards. Second point, starting pay rate. This is a constant shared by all instances of the employee class and cannot be modified. Final methods. First point, prevent method overriding. When a method is declared as final, it cannot be overridden by subclasses. This is useful when you want to ensure that the behavior defined in a method cannot be altered by any subclass. Another example of the employee class has been given. Public, its visibility modifier. Final, it means that it is immutable. Void, it means that it returns nothing. Display employee info, which is the name of the method. It accepts nothing. This is an example of a final method. Next, final classes. Preventing inheritance. When a class is declared as final, it cannot be subclassed. This is useful when you want to ensure that a class's implementation is complete and should not be extended. For example, public final class, employee, and then the class's implementation within the curly braces. Here, no other class can extend employee. Next is final parameters. Immutable parameters. First point, when a method parameter is declared as final, it means the parameter cannot be reassigned within the method. For example, public void change name, final string new name. New name cannot be reassigned. Here, new name cannot be assigned a new value within the method body. Next, final local variables. First point, local constraint. You can also use final for local variables within methods. Once they are assigned a value, they cannot be reassigned. For example, public void, example method. Final int max is equals to 100. Max cannot be changed after this point. Why do we use final? First point, safety and predictability. By making variables, methods, or classes as final, you make your code more robust and less prone to errors, as it prevents unintended modifications. Second point, performance optimization. In some cases, the use of final can help the Java compiler optimize the code because it knows that certain variables or methods won't change. This example was also made possible by ChatGPT. 8.2. An array of stock objects called SARR exists to show the stock of all food items at any one time. An example of data that is stored in the array is shown below. SARR 0. The description is lentil salad. Stock quantity 8. Cost price $5.50. Selling price $8.80. Healthy food? Yes. SARR 1. Description: power oats. Stock quantity 15. Cost price 4. Selling price 6.40. Healthy food? Yes. SARR 2. Description: protein wrap. Stock quantity 4. Cost price 10.50. Selling price 16.80. Healthy food? Yes. SARR 3. Description: Prego steak. Stock quantity 15. Cost price 12.80. Selling price 20.48. Healthy food? No. Fairly Fit has a policy that at all times, their stock of healthy food items must be greater than or equal to 80% of their total stock of food items. For example, if they have 50 items in stock, then at least 40 of those must be healthy food items. Consider the following algorithm, which has been designed to alert the cafe manager if their stock of healthy food items drops below 80% of all items in stock. This algorithm will be tested against the sample data in SARR. This algorithm is within a method called test healthy food, and it returns a string value. It begins at line 1, where total stock is assigned the value of 30, line 2, where size is assigned the value of 4, line 3, where count is assigned the value of 0, line 4, where alert level is assigned the value of 0.00, line 5, where alert is set to level OK, line 6, where we have a for loop. Now this for loop says for k is equal to 0, to size minus 1, increment by 1. Now, the direct definition of increment is the action of increasing or becoming greater. Another one is to increase step by step or by step, especially by 1. So whenever they say increment, unless they give you by 1, you must always know that it will increment by 1. Otherwise, if they say increment by 2, then you know that you have to increase the size by 2 each time you get to that particular step. So now, afterwards, we see the word begin. Line 7 is this code. It is an if statement. If SRR at k.getHealthyFood is equal to true, begin line 8, count is equal to count plus 1, end if, end for. Line 9, alert level has been set to count divided by total stock. This is a real division. Line 10, if alert level is smaller than 0.80, begin line 11, alert must be set to level low, end if. Line 12, return alert, end method. What method will be called to access the value of the variable total stock? The key giveaways in this question is method, access, and total stock. From what we can remember, we created a method called getTotalStock. So that becomes our answer. GetTotalStock. Letter B. You must complete the following trace table to show the algorithm's actions. You must include the line numbers as a reference to the line of code in the algorithm. There are more lines on the grid than are necessary for a correct answer. After answering this question, or perhaps even before, you will find a link in the description which will take you to other videos which will help you to understand trace tables better. This is called a trace table. Now that you know, you may also choose to do research yourself. That is if you are not finding the videos that I linked helpful. Those links, however, were useful in that it gave me the confidence to be able to explain this to you. So please, take a look. Now let us answer the question. The algorithm states that a method called testHealthyFood has been created which returns a string value. The method begins at line 1. Therefore, we write 1. Then in line 1, we have been told that the total stock, which is here, has been given the value of 30. Therefore, we type 30. We move on to the next row. In line 2, we're told that size has been given the value of 4. We move on to the next row. In line 3, we're told that count has been given the value of 0. We move on to the next row. In line 4, we're told that alert level has been given the value of 0.00. We move on to the next row. In line 5, we're told that alert has been given In line 5, we have been told that alert has been given the string value level OK. Line 6, we are given a for loop. Now this for loop assigns 0 to k, and it says that for k is equal to 0 to size minus 1, we must increment by 1, which is literally 4 minus 1, which gives us the value of 3. So in other words, this for loop is supposed to loop from 0 to 3, and we're supposed to increment it by 1 each time. Now that we understand that, all we do is assign k to 0. Before line 7, we begin the for loop. Now, line 7, we are asked if SARR at k dot get healthy food is equal to true. Our value right now of k is 0. So if SARR at 0 dot get healthy food is equal to true. So now what this says is that we're supposed to look at our healthy food status at SARR at 0. Right now it is equal to yes. So now if SARR at k dot get healthy food is equal to true, we're supposed to answer this question. The answer is yes. Yes, it is equal to true. Therefore, we type true. Line 8. If it is equal to true, then we're supposed to set our count equal to count plus 1. Right now, the value of our count is 0. So 0 is equal to 0 plus 1, which gives us the value of 1. Next, we end the if statement and we go back to our for loop, because we're not done with the for loop. We were asked to loop through from 0 to size minus 1, meaning that we're supposed to loop from 0 to 3. Right now, we have completed 0. So because we're done with k is equal to 0, we increment that k by 1. In line 6, our new value of k is equal to 1. Next, we move on to line 7. Line 7 says, if SARR 1, which is our new value of k, dot get healthy food is equal to true. Right now, our healthy food status at 1 is equal to yes. Therefore, it is true. We're supposed to begin this loop. So at row 10, line 7, column 8, we type true. Now we move on. If it is true, we're supposed to begin the line of code at line 8. So we're supposed to set count is equal to count plus 1. Right now, our count is equal to 1. So 1 is equal to 1 plus 1, which gives us our new value of 2. Then we loop again to line 6 because we're not done with the for loop. Here, we increment k by 1. Right now, the value of k is 1, therefore it becomes 2. So in the next row, we move on to line 7. If SARR at 2, which is our new value of k, dot get healthy food is equal to true. Right now, our healthy food status at SARR2 is equal to yes, therefore it is true. What we're going to do is in column 8, we write true. Line 8 says that we set count equal to count plus 1. Right now, the value of our count is 2. So 2 is equal to 2 plus 1, which gives us the value of 3. We end the if statement and we go back to the loop. Now, this is the final time that we'll repeat this loop, because finally, in line 6, the value of our k has become 3, which is where we were asked to stop. Now, in line 7, we're supposed to check if SARR at 3 dot get healthy food is equal to true, which our healthy food status in SARR 3 is equal to no. Therefore, it is equal to false. So because this is equal to false, we're going to type false in column 8. And because it is equal to false, we do not begin the code at line number 8. And because we are also done with the loop, we move on to line number 9. Next row, line number 9. Here, we're supposed to set our alert level equal to count divided by total stock. Right now, the value of our count is equal to 3, and our total stock, as stated in line number 1, it is equal to 30. Therefore, 3 divided by 30 gives us 0.1. Next, line 10. If alert level is smaller than 0.08, so we type line 10. Is our alert level smaller than 0.08? Yes, it is. Therefore, we type true. And finally, if it is smaller than 0.08, we're supposed to begin this if statement at line 11. Therefore, in our next row, we type 11. In line 11, we set our alert to level low. Therefore, from level OK, our alert changes to level low. Then we end our if statement and return alert in line 12. In the return column, column 10, we set return to alert which has the value level low. And that's it. 8.2.2. Line 8 of the algorithm is currently incorrect. Letter A. Explain what is wrong with this line of code. The answer is this. This line of code is meant to sum up the total amount of healthy food in stock and not to count the different types of healthy food. Letter B. Correct the line of code so that the correct result will be achieved. The answer is this. We set our count equal to count plus SARR at k dot get stock quantity. Remember, the algorithm wants us to calculate the total percentage of healthy food and not to count the different types of healthy food. As such, we're supposed to sum up the total amount of healthy food and divide it by the total stock to get the percentage. 8.3. Fairly Fit would like to incentivize customers who use the gym and eat healthy meals in the cafe to lose weight. They wish to apply the following conditions. First point, a customer has eaten 10 healthy meals. Let this equal M. Second point, a customer has used the gym 5 times. Let this equal G. Third point, a customer is within 5 kg of their target weight. Let this equal W. Fairly Fit will reward any customer who has eaten 10 healthy meals and used the gym 5 times, or any customer who has not eaten 10 healthy meals but has used the gym 5 times and is within 5 kg of their target weight. This condition can be written as the following Boolean expression. F open bracket M, G, W close bracket is equal to M times G close bracket plus open bracket M prime times G times W close bracket. Complete the following truth table to represent the condition. Again, you will find links in the description that will take you to videos explaining truth tables in detail. We are told that this expression represents a Boolean expression. Therefore, we're either going to get true or false, yes or no, 1 or 0. So if you find yourself getting 2 or 3, or any other number that isn't 1 or 0, just know that you're wrong and that you should revise your answer. Because we have been given 1s and 0s to work with and true or false as our results, we will work with those. According to the exam paper, where we see a combination of letters and a period sign usually signifies multiplication. So M point G gives us M multiplied by G. M prime, G, and W gives us M prime times G times W. 1 represents true in Boolean language and 0 represents false. So wherever we see 0, we write false, and whenever we see 1, we write true. So now M prime. M prime represents the direct opposite of M. So whenever M is 0, M prime will be 1. M prime literally means the opposite of M. So if M states that a customer has eaten 10 healthy food meals, M prime would state that a customer has not eaten 10 healthy food meals. Now let us answer it. The values have been given to us in the first 3 rows of the exam papers. So here we see that M, which is a customer has eaten 10 healthy meals, has been set to false. Therefore, M prime will be set to true. We write 1. Here is a multiplication. The value for M is 0 multiplied by G, which is 0 as well. So 0 times 0 will give us 0. M prime, which we got as 1, multiplied by G, which was set to 0, and W, which was set to 0. Any number multiplied by 0 will automatically give us a 0. So based on the answers that we got, we are asked to add each together. Mg, which we got as 0, plus M prime times G times W, which we also got as 0, add together. So 0 plus 0 will give us 0. So our answer in the result column will be false because 0 plus 0 is false. The result will be the answer that we got based on the 7th column. Here we got 0, therefore our result is false. Next row. M has been set to 0, therefore M prime is 1. M times G, which is 0 times 0, is 0. M prime, which is 1 times 0 times 1. Any number multiplied by 0, so long as there is 1 0, everything becomes a 0. Because G was 0, everything became 0. Mg, which we got here as 0, plus M prime times G times W, which we got here as 0, gives us 0. 0 plus 0 is 0. Therefore, the result here is false. Next row. M prime. M has been set to 0, therefore M prime is 1. G has been set to 1, so M, which is 0, multiplied by 1 gives us 0. 0 times any number is 0. m prime, which we got as 1, multiplied by g, which is 1, times w, which is 0. So long as there's 1, 0, everything becomes a 0. mg, which is our answer here, which is 0, plus m prime, g, and w, which is our answer here as 0, gives us 0 plus 0, which is 0. Therefore, the answer here becomes false. Next, m has been set to 0, therefore m prime is 1. m, which is 0, multiplied by g, gives us 0. Though g is 1, any number multiplied by 0 is 0. m prime multiplied by g multiplied by w is 1 multiplied by 1 multiplied by 1 respectively. 1 multiplied by itself 3 times gives us 1. mg, which we got as 0, plus m prime times g times w, which we got as 1, gives us 0 plus 1, which is 1. Therefore, our result is true. 1 represents true in Boolean language. Next row. m has been set to 1, therefore m prime will be 0. m, which is 1, multiplied by g, which is 0, will give us 0. m prime, which is 0, multiplied by g, multiplied by w. It doesn't matter whether g or w is 1. So long as we have 1, 0 here, everything becomes 0. The result which we got here, m times g, which is 0, plus m prime times g times w, which is 0, gives us 0 plus 0, which is 0. Therefore, our result here is false. Next row. m is 1, therefore our m prime becomes 0. m times g, which is 1 times 0, gives us 0. m prime, which is 0, multiplied by g, which is, we can just conclude that everything here will become 0. So our result here, 0 plus 0, will give us 0. Therefore, our result is false. Next row. m is 1, therefore m prime is 0. m, which is 1, multiplied by g, which is 1 times 1. Therefore, 1 times 1 gives us 1. m prime, which is 0, multiplied by, let's just say everything will become 0, because anything multiplied by 0 is 0. Next, mg, which we got as 1, multiplied by m prime times g times w, which we got as 0, gives us 1 plus 0, which is 1. Therefore, our answer here is true. Next row. m has been set to 1, therefore m prime is 0. m, which is 1, multiplied by g, which is 1, gives us 1 times 1, which is 1. m prime, which is 0, multiplied by g, which is 1, multiplied by w, which is 1, gives us 0 times 1 times 1, which is 0. m times g, which we got here as 1, plus m prime times g times w, which we got here as 0, gives us 1 plus 0. Therefore, our answer is 1. The result can thus be written as true. Thank you very much.